Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to create the function on TIA Portal version 17 to connect with the PLC S7-300 CPU 314C 2PN/DP, and we can create the HMI touch panel screen, and we can start and stop and reset the alarm to the motor that we can create the function. Yes, what is the function? The function is the logic that we can create inside the block, and then we can call the block to use on the main program, and we can download to the PLC. Then we can use for control the electrical devices such as motors, solenoid valve, or something that we want. Okay. In this section, I will use motor 1, 2, 3. Yes, by create only one FC. Yes, only one function, and we can copy to use with another motors. Yes. So basically we should create the input and output that we want. Example, I have start, stop, overload, reset alarm, and for drive is the output that we connect from the digital output to the contactor or relay to control the motors. Okay, and here is the alarm status. When overload, it will trip the output and then show the alarm. Okay, and if we would like to start the motor again, so we can reset the overload and clear the alarm, yeah, or reset the alarm, then we can run continue. Okay, so for this screen we can create only one, and then we can copy to another two pegs, and then we can change the address of the motor 1, motor 2, and motor 3, so we can control. Okay, so let's go to our software to create the new project of the TIA portal, and then create the screen for test with the PLC S7-300. Okay, so let's go. Okay, so first let's create the new folder. Example S7 PLC S7-300 create function. Yes, and then we can double click on the TIA portal, and then we can create the new project. Yes, so wait a moment for open the software TIA portal version 17. It take time a little bit. Depend on the computer performance. Yes, so let's go to create the new project. I will put S7-300 create function. Yes, and then we can browse to find the folder that we already created on desktop. So this one, and we can command the project as this project will use TIA Portal version 17 to create both PLC and HMI project. Okay, and then click create. The project will create automatically, follow as our field, the project name, the path, and the comment. Yes, and then we can go to the project view. And then create the new device. Yeah, double click on add new device. And then we can choose the controller. I will use S7-300 station. Yeah, I will use CPU 314C 2PN/DP. Yes, it is version 3.3. Click OK to confirm. Actually, we can both connect to the rack with the PLC hardware, and we can also simulation, right? So right now I will connect directly to PLC, but for the HMI I have simulation. Yes, because I don't have the hardware of HMI, but we can simulation. Yes. So right now we already create the hardware for PLC S7-300 CPU 314C 2PN/DP. Yes, here. Yes, CPU 314C 2PN/DP. There are two parts of Profinet and one part for Profibus. Okay. So first let's go to see the hardware. Go to property and then go to input. There are 5 channels of input. Yes. So analog out input has 5 channels, and analog output has 2 channels. Okay. And for the I/O address, analog input, it will start from IW 800 until IW 800H, and for the analog output, it starts from QW 800 also until QW 802. Okay. And for the channel, it is the digital input. It will start from position I 136.0 until 138.7, right? Totally 32 bits. Yes. And there are 16 bits for digital output. So it will start from Q136.0 to Q137.7. Okay, so 16 bits. And then we can go to hardware and then download hardware configuration to the PLC first. Yes. Okay, I will zoom out. Okay, then we can save the project and we can compile the project before download the hardware to the PLC. Okay, no error occur, and then we can go to download. The CPU and PC will detect automatically. So the PLC is address 192.168.0.1. So I will choose the network card that I already connect the LAN cable from my PC to the Profinet port of PLC. Yes. And then we can start search. It will detect the PLC automatically with the PC. Yes. So right now it detects one CPU that has address 192.168.0.1. So we can load the hardware configuration first. Okay, we will stop the CPU, stop all. After that, we can start finish to start the module. It means start the CPU. Yes. And right now the CPU is running. So we can go to create the function that can control the motor 1, motor 2, and motor 3. Okay. So let's go to program blocks. Yes. And then click add new block. Example block motor. So let's choose FC in mean that function. Yes. And then click OK. We will got one function. Yes, here. Okay, so right now let's see the function is motor FC1. Yes. So here we can create the input output that we want to use, right? So basically we have start, stop, overload, reset, alarm, and dry, right? So there are 4 input and there are 2 outputs. Okay. So first I will create the input for start. It is boolean, right? So start command. One more for stop command. And one more for overload, right? So input overload. Actually overload we can connect from the digital input, right? From the hardware of overload, so we can connect to the input. Yes. And this one motor overload. And one more for button for reset the alarm, right? So reset alarm. This one for reset alarm, right? Okay. So right now we already create the inputs for start, stop, overload, and reset, right? So next we can go to create the output we have dry and alarm status. So let's go to output. So dry, boolean also, and we can command as output to contactor, and one more for alarm status, right? So alarm motor alarm. Okay. After that, we can save the project and compile. Yes, no error occur. And then we can create the logic for control the motor, right? So first I will use NC, NO, coil, parallel with the NO, right? And we need the motor alarm. So I will use NC, motor overload, right? So for input, we can drag and drop example stuff. This one for push button stuff. Drag and drop the tag. And this one for start. And one more for output, right? Dry. Okay. And one more for overload. And this one should be dry also, right? Okay. And when motor overload, it will show the alarm, right? Because we have alarm status for output. Yes. So I will insert, and this one we can use the command also. Yes. Example command start and stop motor, and this one should be alarm motor overload. So when motor overload, I will use NO contact, and then I will use set, right? So let's go to our bit logic operation, and then I will use set coil. So when motor overload, I will set the motor alarm, right? So choose the alarm here, and then I will use NC one more for cut the interlock when motor alarm. So when motor alarm, we cannot start the motor, right? Okay. And then I will create one more network for reset the motor alarm. So I will use NO. So when we push the button reset, it will reset the alarm, right? So reset alarm. Okay. So that's all for create the logic for this function. Yes. And then we can save. So this is a stop, start, overload, and alarm. When motor overload, it will show the alarm status to digital output. And then we can push reset after we reset the overload hardware, and then we can continue to start the motor. Okay. So we can compile the program. Yes. And we can go to the our main program, double click, and we can drag and drop the motor FC1 to use. Okay, it will show like this. Yes. So here we can command as motor 1 control, and monitoring. So here we can use start address. Example, I will start from M0.0. This one we can rename the text. Example, start M1. Yes. And this one M0.1. Stop M1. And this one M1 overload, right? So M0.2. So M1 overload. Actually, this one we can connect from the digital input, but right now we simulation, so I can use the M0.2 first. Yes. And reset alarm, I will use M0.3. So reset alarm for M1. M1 reset. And for the output, I will use the digital output, so we can check the address that I already show in the previous. Yes. So we can check the I/O. So output it will start from Q136.0, right? So Q136.0, this one should be M1 drive. And this one Q136.1, this one should be M1 alarm, right? Okay, so that's all for motor number 1 control. Yes, we can save and we can download and then test with the motor M1. Yes, and then we can online. Okay, so right now the output is false. So if I force start, the motor will running, right? Because the output is turned on. Okay, I will modify to 0 and force stop. So the output is turned off. The motor is stopped. Yes. And then we can offline. And if we would like to use with the motor number 2, yes, I will rename this one first. So motor 1. So we can copy for motor number 2. So right click, copy, right click, and paste. Yes. And we can change to motor 2. and then we can create the motor 2, drag and drop the motor 2 here, and then this one we can copy, change this one to 2. Yes, so I will start from M0.4. This one should be start M2, right? Start M2, and then next go to M0.5, stop M2, and for overload I will use M0.6, M2 overload, right? And for reset we can put M2 or ST, so M0.7, so M2 or ST, and for the output I will start from Q136.2, Q136.2 digital output, so M2 dry, right? M2 dry, and for alarm I will use Q136.3, so M2 alarm. Okay, and we can save, compile, and we can copy for model number 3, right? So right click, copy, right click here, and then paste, and rename this one to be model 3, right? So model number 3. Okay, and this one we can copy. So if we have 4 or 5, we can follow this step, copy and paste, and then drag and drop to use on the main program. Yes, so drag and drop the model 3 to the network, and here we can use M1.0, so start M3, M1.1, start stop M3, and for overload M1.2, M3 overload, yes, and for reset M1.3, so M3 or ST, and for the output I will use Q136.4, M3 dry, right? Okay, next the last one, Q136.5, M3 alarm, and then we can save the project and compile the program. There is no error, right? And then we can download the logic to the PLC. Yes. When we tick like this, let's see here, it becomes to FC2 for this one, FC3 for this one. After load, we can check again. This one should be FC1, this one should be FC2, and this one should be FC3, right? So let's start to download. Yes. Let's see here, FC1, FC2, and FC3. And then we can online to see the status of the function. Yes. Okay. So if I would like to start the motor number 2, I can push start. Yeah, true. And then we can stop. False. Yes. Okay. And if we would like to test for the overload signal, we can test. Yes, alarm, right? If we remove the false, it's still alarm, so we need to reset, right? Okay. Reset, and we can remove this one to 0. Yes, to be the normal condition. Yes. Okay, so we can create the HMI the same as this one. Yes, to control the motor one by one. So I will outline first and then save again and add the new device for create the HMI. Yes. And then I will use the schematic comfort panel 7-inch. Okay, so wait a moment for create the HMI device and click finish. Okay, then we can delete this one. Okay, delete first, and we need to create the connection, right, to connect with the PLC. So go to connection and then insert the new connection. Example, PLC S7-300, and I will connect via Ethernet, and here is the IP address of computer, so we can check with the cmd IP config. Okay, so 192.168.0.253. So I will put this one with 253. And for the PLC is 192.168.0.1, right here. We can check the property, Ethernet address, yes, this one 192.168.0.1. Yes, So that's correct. Save, and then go to create the text for HMI, right? So go to the show all text. So the first one, we need to create the M0.0 for start M1, M0.1 for stop M1, sorry, M0.2 for overload, M0.3 for reset the alarm. Yes. So let's go to HMI text. So M1 start or start M1. So the data type is Boolean. So we can choose Boolean, and the connection of the PLC, we can use the PLC S7-300 that we already create here. And then we can use the address M0.0, right, for start. Okay. So stop M1. The address will generate automatically. Yes. Let's see here. M0.1. And the next step, M1 overload, right? M1 reset. Yes. And then M2, start M2, stop M2, M2 overload, M2 RST. Yes. Let's see, the address is generated automatically to be the same as the address that we put here. Yes. So it's very easy. After that, we can use start M3, right? Stop M3, M3 overload, and the last one is M3 RST, and we have output also, right? So output, it will start from Q136.0. Yes. So M1 drive, and then we can change the address here. Q136.0. And the next M1 alarm, right? Here, M1 alarm, and then M2 drive, M2 alarm, M3 drive, M3 alarm. Yes. So the address start from Q136.0 until Q136.5. Let's check here. Q136.0 until Q136.5. Okay. And then we can go to the root screen and create the start and stop for model number 1 to number 3. Yes. I will change or create the title for this animation. Go to apparent and then change the color to be this color, and I will change the background of the screen to this color also. Yes. Okay. And then we can create the label TIA Portal version 17 connect with PLC S7-300 create function. Then I will change the color to be yellow, and this one we can change apparent layout. We can change okay this color, and then I will select to center. Yes, like this. Then we can simulation, yeah, to test the text title. It's very big, right? So we can adjust the size to be 15. Here we can select the layout and uncheck the fit object to contents. Yeah, so we can adjust so big, right? Maybe 19 is okay. So big, right? We can adjust to be 17 and test again. Oh, good, right? That's okay. So we can create the button for start and stop the motor. Yes. So I will choose the rectangle and then change the color of rectangle. I will use this color, and then we can use the label motor 1, layout, and uncheck the fit object. Yes. and this one I will use white color. Yes. Okay, and we can insert the push button. Yes, example this one for start. So go to property and then go to the general apparent, then I will use solid and change the color to be blue because it is start button, and we can adjust to be 25 for the size. Yes, and then we can copy for button stuff. Rename this one to stuff and change the color to be red. And both text file I will change to black color. Okay, like this. And let's go to insert the motor. Okay, I will choose this color. Yes, like this. And then I will use the rectangle to show the status of motor. Yes. This one maybe I will use the yellow color. Yes. And this one we can change the color to red. It is the normal or motor is stop status. So it will show the red color. Yes. And then we can configure the button start, stop and status of the motor, right? So let's go to start. Maybe we can increase the size a little bit more. Yes. So right click, go to event. Yes, because we need to press to start the motor, right? And then go to set. We can use set bit Y key press, right? And here we can go to default text table. Single click, yes. And then we need to use the start M1, right? So let's go to M1 start. Yes, start M1. So drag and drop the text to the event here. And for the stop M1, we just click here and then set bit while the key press and stop M1. So drag and drop the text to here. So that's all. And for color animation, we can go to color animation of the motor. Yes, right click animation and go to display, add new, so we can choose the apparent, yes, and then we can drag and drop the M1 drive, so M1 drive, drag and drop here, and here we can change the status. If one, we can change the color to be green, yes, and we can copy one more for motor alarm, right? Because when the motor is alarm, we should blink the color, right? Another color. So right click, and then we can delete this one and drag and drop the motor 1 alarm to this one, and then change the color to be this one and also blink, yes. So we need to hidden when the motor alarm, we need to hidden this one, so it will appear this one, yes. So to do that, let's go to create the new for animation and choose the visibility. So when the motor M1 alarms, drag and drop from 0 to 0, right? And invisible, yes, like this. And basically we can test the function is correct or not. Okay, so right now the motor is not alarm, so it hidden, right? So if I force the signal for motor number 1, we can online. So let's see here, I will force the signal for motor alarm, yes, motor overload. Let's see, the screen is pop up with the blink, right? And then we need to hidden this one. So go to root script, and then this one, right click, animation, and then go to create the new animation, visibility also. And when the motor is alarm, we need to hidden this one, so we can use the alarm here. So we can hidden the status of the motor when the motor is alarm, right? So we can go to one, and then visible, yes, and then we can test again. So it doesn't correct, right? So we can change to be invisible. Yes, so this function is okay. So we can go to unforce the alarm, right? And then I will reset the alarm. And let's see, the screen is okay, yes. So here we can move to be the same position. Yes, like this. So when we start the motor, the status will be green. Yes. Start. Yes, green. Stop. Blue. Sorry, red. And then we need one more button for reset the alarm, right? So we will create one more button. Basically we can copy and paste. This one for clear. Or reset. And then I will change the color of button to be this color. Yes. And we need to change the address, so go to event, freeze, and then go to M1 reset, drag and drop to this one. Yes. And we need to show the status of the motor when the motor is running. Yes. So I will adjust this one to be small a little bit. Yes, like this. And then we can use the text label running. And check the fit object to contents. And then we can change the color to be, I will select solid and then change the color to be green. Center, yes. So when the motor is running, then we can show this one, yes. So go to animation, create the new visibility, and use the M1 drive. M1 drive. And rank from 1 to 1 or from 0 to 0. Yes. Okay, let's simulation. So when I start the motor, it will pop up the running, right? This one. So that's correct. So I will adjust this one a little bit. Yes. And we can copy for motor number 2 and number 3, right? So select, right click and then copy, right click and then paste. Yes. for motor number 2. And one more for motor number 3. Yes. So that's good. And we just change this one to be motor 2. This one to be M2 drive, right? This one to be M2. This one M2 also. This one M2 RST. And for this one is animation, right? So change this one to M2. Visibility, change this one to M2. And one more. This one we can change to M1, change to M2. Animation also change to M2. And then we can go back to normal. This one we can change to M3 for the status. Animation, apparent, change to M2. Visibility, change to M3. This one also change to M3. This is just basic. When we create the faceplate, we can do faster than this. I will show in the next video. Yes. So M3. This one change the event to be M3. This one M3 RST. Okay. So we can adjust this one to be center, the same position. And we can save the project and then we can simulation. Yes. I think it worked perfectly. Okay, so we can go to main OB1. Okay. So we can online like this. I will adjust the space for easy to see the status. Yes. So right now the motor 1, 2 and 3 is stop, right? So if I push start M1, yes, let's see the motor number 1 is turned on and output is turned on also. Start this one. Let's see, here is turned on. And for the motor number 3, I will start number 3. Yes. Oh, this one not work, right? Let's check the push button. Let's check the push button. Start. Go to event. This one should be M3, right? Okay. Sorry. Mistake the address. Yes. So save the project and then go to simulation again, and go to the main OB1 again, and let's test again. So if I push start M3, let's see, M3 is turned on, yes. If I stop, start again. And example, if the motor M3 is overload, yes, let me force the signal to be overload. Let's see, motor M3 is alarm, yes. And then we can unforce. It's still alarm, right? We need to reset because we use the set function on the output, yes. So if we start, we cannot start. We try to start, the motor is not run, right? So we need to reset the alarm and then we can start the motor. Okay. So motor number 1 and number 2 is the same. Yes. So it worked perfectly. We can stop, start again. Yes. So this is just example about how to create function to control the motor by using the PLC S7-300 with the TIA Portal version 17. Yes. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And in the next video, I will show and share about how to create the faceplate for this one also. Yes, it's similar to be this one, but we can do faster than this. So I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.